My name is Gabor Wnuk. This is the first time I'm here, so a few words about me. I'm from Wirtualna Polska. I've been there over 10 years now. And I joined the company as a PHP developer. Then I moved to Python. Then I became an iOS tech leader. And for the last 6 years, that's what I actually do. However, recently we've moved towards React Native, so that's why I'm here. In fact, currently I'm responsible for the architecture of our content mobile products, and these are both iOS and Android native apps, as well as mobile progressive web apps. So, yeah, and currently around 60% of our users use our products using their phones. So, from around 4 billion page views they actually do every month. Around 2.5 billion is made through mobile devices. For the last few months, I am doing React Native keynotes and events, and that's why I decided today I will talk more about the other stuff and throw away a few slides about React Native. I've left around 5 slides about React Native because today you had the chance to hear about React Native on, I think, 2 other talks. So if you want to learn about React Native more, you can check out my 2 presentations. One from JS Poland, I think it was in, let's say, April or May. And the second one was on DevJS Warsaw in Google Campus, I think, 2 months ago. First one is in English, second one is in Polish, so yeah. And you can actually download our application, a Pudelek application. It has around 500,000 users currently. And it's a pure React Native application. It's first it was like a brownfield project where we rewritten a few parts of application to React Native, and currently it's pure React Native application. So yeah, but back to the topic. Winter is coming because we have October, and I think one of the topics which is quite popular recently is obviously smog. So. I wanted to ask by the raise of hands how many of you have been in Warsaw during the winter, but yeah, probably everyone. So yeah, So this picture was taken on January. It actually doesn't look better on my screen because yeah, that's actually how it looks like. So this picture was taken around 10 a.m. and yeah, that's how the city actually looks like. This is not like a humid, cold air. This is actual air you can see actually in Warsaw. And the main reason is, and the main fault is on the side of the districts around Warsaw, because everyone wants to heat up his home using low quality coal and plastic bottles and so on. And the sad thing is that Warsaw is not worse in this competition, because this is Krakow. And this one was shocking for me, because I always thought that Krakow is the very, very clean city. But yeah, this is how Krakow actually looks like. And they have really, really big problems with the air quality. And this one is, yeah, this is Zakopane, and this one is actually quite funny because yeah, this is also smog. This is not some kind of fog. If you book your apartment, let's say through Booking.com or Airbnb and so on, every booking has added something called environmental tax. So this tax is due to the fact you can breathe this air. So yeah, they are, yeah. So yeah, and this example is actually an article from the Financial Times, and this is the more radical example, because there is a place called, this is a city or maybe small village in southern Poland, and Skała is actually worse in air quality than Beijing. So yeah, something we can be proud of. So I took a while and I've compiled this simple chart. So. The causes of death in Poland, this is 2015, because I had sources from 2015, and if you want to check out if everything is okay with the numbers, you can just go through those sources and you can check every single one to verify. So it happens. No one was killed by terrorism, so yeah, that's cool. One person was killed by Sosnowski's hogweed. I will elaborate about this plant later. Some people were killed by a car, and 47,000 people were actually died because of the air quality and diseases related to the air pollution. So yeah, and to like compare it with what Poles fear most. So everyone is scared of terrorism. Everyone is scared of Sosnowski's hogweed. Some people are scared about being run over by a car, and no one actually cares about the air pollution. So yeah, and about the Sosnowski's hogweed, this is actually this plant. This is a screenshot from one of the Polish tabloids. This plant with teeth and so on. So yeah, that's something you can learn about. Okay, so. Actually, in this talk, I won't show you how to fix all those problems, because actually the only thing will be you being more scared and terrified about the air quality around you. So I will show you how to create your own personal air quality measurement system, and using a few lines of code how to verify the air quality in actually this room. So yeah, so we'll use two devices, in fact. This one is called ESP32, and the entire device is called ESP Room. And actually, I've chosen this one because this one has Bluetooth LE. So if you want to create something low voltage, this is something you can use. There are also ESP12 and so on, cheaper ones. This one costs $8. You can find one like ESP12 for $2 or so on. So yeah, you can also buy from the Polish company called Botland, and they of course they are not so cheap. So yeah, and the second thing will be something called SDS011. This is quite a smart device because it has this pipe. Through this pipe, air is being sucked by the fan here, and it goes through a laser. And yeah, this way you have a measurement from the device. Okay, so because everyone who was interested in programming a microcontroller know that usually you program your microcontroller or Arduino program using C++. So that's usually how it looks like. And because I wanted to show you a few examples in ReactNative, and ReactNative is JavaScript, we won't use C++, we will use JavaScript to program our microcontroller. So first of all, we have to connect our device, our ESP32, and if you have your OS X, sadly, on OS X you have to download some drivers and so on. That's something quite strange for OS X users, because usually you don't have to download anything. But this time you have to check whether it's actually visible in your system. If not, just download your drivers from this side. There is a source on the bottom. Install. Again, unplug and plug in your device, and it should be visible as this USB to UART device. Okay, so how do we install JavaScript interpreter on such a device? There is something called Espruino, and Espruino is, to put it in a few words, first of all, it's open source, and it's I like a JavaScript interpreter on a microcontroller. It's about 95% compatible with standard JavaScript. So you can imagine that this is in fact their own implementation. They haven't used anything existing. And what I found, you won't be able to find any differences if you create even quite complex projects. So yeah, we'll use Espruino. So simply, you have to build the firmware. First of all, clone, then do some provisioning. If you own OS X, you have to read something more about how to install a compiler, which will be able to build the entire project. And normally you just do make clean and make, and you build like a normal project with make file. So You have your own firmware build, then you have to upload it to your device, and this is the first step. You will be able to verify whether your device is actually visible by your system. So those parameters are quite self-explanatory. So yeah, you chose your ESP32 port, baud. You actually determine which speed you want to use, a few additional parameters, location of your firmware, and that's actually all. This will take maybe 2 minutes, I think. So this is quite fast. So okay, so how many of you have actually programmed any microcontroller before? Most of you, I think. Okay, not most of you. Okay, so. Usually, if you buy any Arduino, any Raspberry, any ESP, you have this chart of available IOs, and in this presentation we will use actually 4 of them. So obviously GPIOs, which are like completely standard pins which can have 2 values, high current and low, high state and low state. So you can use this GPIO to light your LED, but you can also use, let's say, 2 of those GPIOs to create serial communication, because you have low state and high state. You can actually use it to create quite advanced things. Second of all is obviously voltage input. So we have on this device we have 2 of those, 5 volt and 3.3 volts, and we will use the 5 volt to actually power the device, this SDS011 device, because on this 3.3 volt it won't work at all, and obviously ground. Yeah, it's normal. Okay, so to develop any code on Espruino, you will have to install something called Espruino Web IDE. It's quite simple extension to Google Chrome. You just download it from Google Chrome Store. It works very well on the Chrome, and it doesn't work on Safari at all. So yeah, you have to download Chrome and use it to at least to do this thing. Yeah. Okay, so it looks like this. On the left side, you have your output from your device, few icons, and on the right side, this is the place where actually we will see our source code. So yeah. Okay, so I will show you small piece of code which will able to verify whether actually the device works. The firmware is interpreting our JavaScript correctly. So this maybe we'll use some small example, small callback to print out some stuff from our device. So this is the simplest thing you can do. You just put your function to repeat it every second, connect, upload, and every second you will have this callback executed on your device. So yeah, in this example we have, there's just a simple hello, but this actually tells us that everything is set correctly and we can do more advanced stuff. So next we will try to connect our air quality sensor to our microcontroller. So we have to use 4 pins, as I said, GPIO 16 and 17. In this case, every device you will buy probably have all those pins signed, subscribed. You can just read those names from the device itself. You don't have to even download any manual. So TXD, RXD is transfer and receive pin on SDS011. We will connect them accordingly to GPIO 16 and 17, obviously ground and 5 volt VIN to connect the device. So in this example, we will try to receive any data we will have on this serial 2. It's actually, if you read the documentation, serial 1 or serial is used by USB to communicate with your device. So if you have it connected to your notebook, the serial port is, well, it won't be available. So we have to use serial 2. We set those pins we've connected our device before, 16, 17, and on the data event we will try to print our buffer from our device. So this should look like this. Okay, so we have our data from our device, and this is actually how it should look like, because this is a binary data. They use 8 bytes, I think, to tell you what is the quality of the air you have around your device. So now we will have to translate this binary data to actual numbers. So if you read the documentation of SDS 011, you will find actually how this structure, this struct you are receiving from the device, what each byte does actually mean. So the second and third is for PM 2.5. It's I think it's a name of those particles which have 2.5 micrograms on meter cube, I think. This one is actually more dangerous because it actually is going through your lungs to your bloodstream. This PM2 these particles are quite bigger, and they actually are left on your upper respiratory area. So yeah, this PM 2.5 is more interesting for us. So we just unpack this structure. We want to have those values in our object returned from in this parse SDS function, and every second we will have actually every second, because this device the frequency is 1 second, 1 hertz. So we don't have to put any delay and so on. This will be every single second. So this looks like this. Yeah. So for PM 2.5, I think the danger level is around 50 micrograms. So yeah, we're quite fine. But this value is for Poland. I think in Belgium, this is like the danger zone. So yeah. Okay, so we have our data. Now we would like to broadcast the data with some kind of protocol. So obviously we can use Espruino lets us to use existing libraries which are for HTTP server, for Bluetooth, and so on. So we'll obviously use the HTTP server. So we'll create a server on port 8080, 8080. The only slight modification here is we are currently assigning our data values to global variables to use in our callback on created server. So every connection will be responded with the JSON with 2 values, PM2 and PM10. So let's see how this looks like. Okay. Okay, this one is, I think. Okay, so let's go through another slide, I think. Okay, so because we need some kind of connection with our network, so we have to create a Wi-Fi connection to our existing wireless network. So this is actually my network in my home. You just put your SSID, your password, and yeah, you should in our console log we should have our IP, which will be provided by our router. So let's check this example thing. Okay, this is quite weird. Okay, so let me just try to play it this way. Okay, so I'm not sure what this doesn't play back, but okay, so we'll just try to. Okay, so the only reason, the only thing here will be you will be provided with the IP we will use to connect our web browser. So I think this is something we can simply check by uploading the firmware here. So let's upload everything here. Okay, so we are with our IP connected to our wireless network. So currently, if you would like to check the quality of the air here in this room, I will show you the IP and the network of you can use to connect your device. Using Google Chrome, okay, any browser, we're trying to connect to our device on our network. So yeah, this should actually work. So yeah. And every single time you will refresh your browser, you will be connected to the device, and you will receive the fresh data from your device. So yeah. Okay, so if you want to check the actual quality of the air in this room, you can just connect to my iPhone if you're lucky. Use this password and try to put the IP I've got here. So yeah, if you want to create, want to connect and check out this device, should actually handle quite a lot because the ESP32 has around 80 megahertz, so it's a quite powerful device. Okay, so as I promised, few slides regarding ReactNative, because actually to utilize the data, you can currently use any technology, but in this case, I will give you an example in ReactNative. So obviously, as usual, you create your ReactNative init. You just run your application, and you have your standard boilerplate welcome screen. So yeah, you can use it. You can launch it on iOS or Android. The simple piece of code here is yeah, we just set our state to initial values. We are connecting to our actually we create interval to refresh every 1 second and to make a connection to our IP of our device of our ESP32, and yeah. In our render method, we actually create just a simple view with 2 values. It will be every time we'll change the state of our component, the values will change, and we will have our measurement on our screen. So this should look like this after refresh. So every second we have a new measurement. Yeah, and actually it does work. So you can obviously use some components. You can just put the data in any kind of visualization. So yeah, this should look like this. Yeah, the values I think change. Yeah, sometimes. Okay. So my final suggestions are few actually. You can use, actually you should use some kind of low energy communication. First of all, Bluetooth LE. You can use an existing library from PolIdea. Guys created ReactNative library for Bluetooth LE. I think it's quite popular. So yeah, you should use it, and you should try to use a deep sleep of your device every time you can, because currently the lifetime of this air quality sensor is about I think half a year of constant measurement. So you can just try to take a measurement for, like, let's say 20 seconds, maybe 1 minute, and just put it in deep sleep. I think the sweet spot is around 30 seconds for measurement and sleep for a few minutes, because yeah, just like that, and you will extend the lifetime of your device for a few years. So this is quite cool. If not, try WebSockets. But the drawback of using WebSockets and Wi-Fi is you will have to be connected to your Wi-Fi constantly. So yeah, this is quite a big drawback. As I said, use deep sleep and for your SDS and for your ESP, because also ESP both with SDS allow you to use your deep sleep and average your measurements. Sometimes if you just walk by your device, those values will just skyrocket, and you will have this peaks of your measurements, and this data is actually obsolete. So just ignore it. I am currently taking around 10 measurements to average every single one. So this looks quite nice. Okay, so From me, it's all. That's all. Obviously, we are hiring. Yeah, we are looking for ReactNative developers, Golang, Python, and so on. So if you are interested, just go on the webpage and send your CV, your contact, and so on. And that's all. Thank you.
How can you use those tools that you just presented in ReactNative to the next step? So you can detect very easily that the air quality is not that good. How to improve that using those tools?
Yeah. Actually, this is just to make aware people that the air quality they are actually used to is not so great, because as with, let's say, cigarettes, the effect of smoking is not immediate. After a few years of smoking, yeah, that's where the problem starts to happen. So, yeah, this is just to make people aware of the problem, not to solve it itself.
Okay, thank you, Gabor, for a great presentation. You mentioned, at least in the title, that doom is coming, and do you think that we will all die because of air pollution?
Yeah, well, currently it's around 50,000 people, but yeah, this. I don't know if I said in high school I used to live in a city which had around 50,000 people. So yeah, you have one entire city gone every year. So I think that's quite a big problem.
Is there a difference in measurements if the sensor is on a ground level and somewhere high? There are big differences?
Yeah, and actually quite huge, because a few months ago we took measurement on the bottom of Warsaw Spire and on the, I think, 40th floor, let's say, and the difference was actually quite big. It was like 2 times, and on the ground level it was actually better. So yeah, so that was quite weird. But I usually compare my measurements with the official ones. So just to have this like a point of reference, whether this thing actually works fine. So yeah.
And it turns out they are lying?
Sorry?
And it turns out that the official ones are lying?
No, they are actually because I live. I live next. Let's say not next, but like 5 kilometers from the official station. There is a difference because obviously it's 5 kilometers, so you can have your like just nasty neighbor, and this will make the whole difference in the air quality. So yeah.
This is the first time I heard about Esprima. That I was reading about it. So is ECMAScript compliant? But of course it's not JavaScript, so I guess that you cannot debug this.
No. This one is no ECMAScript. No. This is just plain old JavaScript. I think from, let's say, 2000 and maybe 10.
Really?
So.
Because I was reading the Esprima docs,
yeah,
and says that it's compliant with ECMAScript 2016.
That's weird. I used few let's say few nice things from ECMAScript, but it's obviously it's not compatible with this. Yeah.
Weird. Maybe they update the release.
maybe, but that's fine. Actually, that's cool. Yeah.
And there is a way to debug this code?
Not really. Because if you do something which the device won't actually be able to process, you will have this device crash and entire stack trace, and yeah, so you won't be able to. You can obviously divide by 0, yeah, and this will crash. This Esprima Web IDE won't tell you that this is a problem. So this only validates your syntax.
Okay, so the code is compiled in the browser and sent it to the device, or the code is compiled in the device?
No, it's not compiled. It's the code and the entire thing is bundled and sent to the device.
Ah, okay.
So the entire
the device run this code.
Yeah.
So the device.
Yeah. Because there are different solutions, which, as I said here earlier, there are solutions for Arduino. But Arduino won't be able to execute JavaScript code because it's too simple. It's like a transcompiler. So it's compiled on your computer, and the binary code is sent to Arduino. So that's why it's just like a build any binary code.
Okay, thanks.